Hi, this is Kevin Trainer, and I'd like to welcome you to my tutorial demo on unit testing with JUnit. And today, what I'm going to demo is further unit testing of the counter class. Uh, in this time, we're going to use JUnit instead of traditional custom client that we create for testing. So the first thing I'm going to do, this is all in my demo project, Chapter 8, Part 1 demo, and I'm going to want to copy that project, and I just want to show you you can copy projects just the same way you can copy just about anything else in Eclipse. So highlight it, right click, copy, um, right click in the package explorer again, say paste. And I'm going to call this chapter 8 part 2 demo, and I can get rid of that copy of. Okay. All right, so let's go look at chapter 8 part 2 demo. And it's got one source folder, and currently I've got two packages. I have the package that I put a counter into, okay, net.ligent.students.counter, and I've got counter and counter client there. And then I've got the package that I put car into, and I've got a car and car client. And I also, in the last online class that we did, I created a demo car class features. Okay, so I'm not going to be fooling with transportation quite yet. I'm going to be working with counter. So the first thing I need to do is to set up my project to have the features that it's going to need to work with the JUnit testing framework. Okay, and a really primary one that absolutely has to be done is we need to connect our project to um, the code libraries for the JUnit software. So there's a number of ways to do this, but I think the easiest one is to highlight the name of the project, right click, and then, let's go down and click on properties. So I get us into the properties dialog. Okay. And the libraries that are connected to our project are determined by this Java build path, this third option. So let's do this. And depending upon the last thing that was done in your project, you might be on the tab for source or projects or order and expert, but um, hopefully when you come to this part of the dialog, you'll just be on the libraries tab like I was. And this is pretty easy. We want to add a library. And so we're going to go down over on the right side. There's a button for add library. And again, what could be highlighted could be probably almost anything here, but you want to highlight JUnit. And you want to click on next. And it's going to suggest that we want to use JUnit 4, which is exactly what I want us to use. So then let's click on finish. And as we can see, there's now a library for JUnit 4 here. That's great. Let's say OK. And when we come back to our project, we still have our source folder. we still have our JRE system library, but look, we have a JUnit 4 system. We have a JUnit 4 library as well. Okay. So now we have JUnit features alive in our project. You have to turn them on project by project. And now we have it on in our project. We're going to use a practice that's really become pretty well standard by the Java developer community, and that is the Java developers who use Eclipse and who use JUnit tend to put their test code in a separate source code folder from their production code. So we have one source code folder now, SRC, which is kind of short for source. And that's broken up into packages. Okay? And what we're going to do is we're going to create another source code folder. So highlight the name of the project, right click, and say you want a new. And it's really easy to get the wrong thing here because what we want is source folder. Now there's a normal folder, there are all kinds of other things that look like it, but we want the little one that has the package icon and all, source folder. And we're going to call this lowercase test, test. And we're going to click on finish. And so now we've got two source code folders. One's going to hold our source code and the other is going to hold our test. And the next thing we're going to do is we're going to create a corresponding set of packages in the test folder. Okay, so the one that we're working on now, net.logent.students.counter, we have one in the source folder. Let's make one in the test. So I'm just going to highlight test. I'm going to right click. I'm going to say new package. And I'm going to say the same thing, net.logent.students.counter. And there it is. When you create a package and it doesn't have anything in it, the wrapping paper is white instead of brown. Isn't that cute? I absolutely love that. Okay, so if the class we're trying to test is counter, we have that up here, we are going to test it with a class. This is, again, another widely accepted practice. A class called counterTest. And it's not just a normal Java class, it's a special animal. It's a JUnit test class. So let's highlight this empty package that we want to hold in. Right click, say we want a new, and let's look. Here they call a JUnit test case. Now that's a misnomer. But we're going to call it that because that's what they call it. It's really a JUnit test class. So let's say that. And what are we going to call it? Well, what we'd like to call it is the same name as the class we're testing, counter, plus the word test on the end. Okay? And we can ask for some stubs to be created for us. Now I'm just going to click setup here. We're not going to use it right in the beginning, but I'm going to show you how to use it eventually, okay? So we don't want the other three, just the setup one. And click on finish. Okay? So this is a pretty interesting class, okay? Now let me point out some things. That even though this test class, counter test, and the class itself, counter, are in two different source folders, we've told them that they're in the same package. So we're going to be able to make a reference to the counter class without having to do an import. And that's the reason why we created a parallel package structure. Well, why do we need two sets of source folders? Well, what we're going to find out is that it makes it really easy to run all of our tests. Okay, because we're going to see in the beginning we're going to run just the test for this class. Then we're going to see we can really easily just simply over on the package explorer we can highlight the package is holding a bunch of test classes and run all of them in the package. And then we can highlight the test folder and we can run all the tests in our system. So this ability to run all of our tests easily is what is the payback from the little nuisance of having two source code folders, one called source and one called test. Okay? So it's a little bit of a pain, but it's got a big payback later. All right, so let's look at over here. So the package is the same as the package for counter. We have imports for JUnit classes. So the package name, there's a package org.junit.assert. There are a bunch of things we're going to be using from that. There's org.junit.before, org.junit.test. Having these imported mean that we can use the parts of the JUnit infrastructure without having to do any further imports. Okay, so here's our class, counter test. And we have a bunch of methods, okay? And before each of these, I may have called attention to these before, but these things that begin with the outside, they're called annotations. And these are compiler instructions, okay? So this tells the compiler, the Java compiler, that we want to give some special treatment to the part of the code that comes immediately after the annotation. Really, these annotations are metadata about our class. And every test case that we run, every test is going to begin with a test annotation. Then it's going to have, for right now, we're not going to use the before. So let me comment that out. Okay, so right now we just have the test. Okay, so we have something that it's just called public void test. So every test method in our test class is public. It doesn't return anything explicitly, so it's void return type. And by convention, it begins with the name test. Okay? What we do is that we add on to the name test descriptive things that describe the test case that we have. Okay, so let's just look. I want to go back and I want to open two things. I want to open the counter class. This is up in the source folder. And I also want to open the counter client class because that's where our original test was. And our testing strategy for the counter class was pretty good. It's just that because of the kind of testing that we were doing, we had to keep inspecting the output. Well, as you're going to see, we're not going to have to do that with JUnit, the JUnit style of testing. This makes it much easier to retest our class. something that we're going to want to do pretty religiously every time we make a change to code that's in the class, because we always want to show that our new code passes the test, the new test that we've added, but we also want to show that our old code hasn't been broken. And how do we know it hasn't been broken? Well, it passed the old tests. And we can run them without having to do all this expect value equals 0, expect false, expect true. Okay, so here's the counter class. It has one instance variable value. It has one no argument constructor. It's got getters and setters. The setter for value is private because we don't want people setting it from outside. The getter is public. It has a toString. It has a hash code and an equals. It has two worker methods, increment and decrement. It's very much like your pedometer, okay, that you did. Okay. So let's go over here. Let's go to the test. So the first thing I want to do is I want to test the no argument constructor. Okay, and what do? Well, I construct one, and then I print it out to make sure that it's there. And I'm expecting it to have a 0 value when I print it out. Okay, well, we can do a little better than that in counter test. Okay. So let's call this test no arg constructor. Can have any name. Okay, that's a really nice thing. Okay, and what are we going to do? Well, we're going to construct one. So we constructed one over here in counter client. Let's just steal that. Okay, that was a perfectly good constructing. So now we've got something C1. So when we come back, okay, we have this variable C1 that has a pointer or a reference to a counter object. And we just want to make sure we have a proper counter object. Now, one of the things that we do in the JUnit framework is we get the results that we want, and then we make assertions about them. Okay, and then the framework tests that those assertions are true. And if the assertions that we make are true, then we pass our test. So, what could we assert about C1? Well, typically what I do here is I just assert that it's not null. Okay, well, I could do a test for equal null, but it turns out that there's a built-in assertion that is part of JUnit, and what we do is we call a method called assert not null. So we say assert, capital N for not, capital N for null, and we say C1. Okay, and that looks good. So if in fact it's not null, I'm going to be happy that I got a properly constructed object back. I've got a pointer to a proper counter. That's enough for me on a no argument constructor. Okay, because I'm not expecting to have set any particular values, right? All right, that's good. Okay, so let's run a test. So we run this pretty much the same way that we would run a test on a regular class, but we make a slightly different choice. So I'm going to go up where the play button is, click on the drop down, and I'm going to say run as, and what do I get? JUnit test. Well, that's just what it is. It's a JUnit test class. And when it runs, and if it succeeds, we get a green bar. So what it does is it runs every test case that we have. Right now we only have one. Okay. Pretty soon we'll have two and then three and then four. It runs every one. Okay. And if they all pass, we get green. Well, what happens if we get a failure? Well, you only need one failure. So it turns out that there's a special part of the framework where you can force a failure. So I'm going to force a failure right here. I'm going to say, well, what if that test case failed? Okay. So this just forces a failure and the test comes to a halt. Okay, I'm going to save it and run it. Comes up red. That's cool. Now, which test failed? Well, we can look down here as a list of the tests. Oh, it's a test no arg constructor. Okay. And then we have down here a failure trace. So it says where we are. So we can actually go down here and double click. Oh, this is the statement that blew it up right there. That's where it failed. Oh, that's what we're expecting. So since we forced a failure there, I'm going to delete that and I'm going to save it. And I'm going to run the test again, just have to press the play button. And now I have that lovely green again. Oh, isn't that nice? Okay, so each of these tests has this has the pattern that we've seen. It starts with the test annotation. Okay, it's public. It has a return type of void, and it takes no parameters. And it can have an arbitrary name. By convention, we begin with the word test, and then we describe the test case that we're testing. Okay? Typically, we're testing one thing. All right? Now, there's some disagreement among practitioners about one thing is. What I'm going to teach you to test is I'm going to test you one test case for a method or a constructor. Okay, so the no argument constructor can only get called in one way. Okay, because it can't pass any parameters to it. It's a no argument constructor. So I think it only needs a single test case. There are some methods or other constructors that we can call in more than one way, in which case we may need more than one test case. Well, how many test cases are we going to need? Well, if we look at that counter client, I kind of had you create things that are pretty much what we're looking for. So the next thing I want to do is I want to test the toString. Okay, let's do that. Let's go back to counter test. Now let's create the next one by hand. Okay, so I skip a blank line. The annotation, @ capital T EST, lowercase won't do it. Okay, and then the method header, public void test toString, paren, open curly brace, close curly brace. Now, I'm going to show you an important trick here. It's going to become in a couple of weeks when we get with when we do a little bit more work with test-driven development. What I want you to do, I'm going to want you to do this in a more specific way. But it turns out it's important that the first thing you do with your test is you force it to fail. That seems odd. But let's see this. Okay, so we're just going to type in a call to fail, okay, which is part of the JUnit infrastructure. That's why we can call that method. If we hadn't imported all this JUnit infrastructure stuff, it would not work, okay? And now let's run it, and we're expecting it to fail. Well, you might say, Kevin, that's kind of silly because, yeah, you forced it to fail. What have you proven? Well, what Kevin has proven is that this test is actually running. Because let me show you what happens if you accidentally forget to put this test annotation on here. So we're just going to get rid of this. Okay. So the framework will run every method that has a test annotation. Okay. Watch what happens when we leave the test annotation off of test toString. It passes. We get a false pass. Why? Because it never calls test toString. Ooh. So if you want to be sure that every test case that you add is really wired in, then you're going to want to begin with a forced failure. Okay? Otherwise, you could have a false pass. Okay? And let me tell you, people do it all the time. I've done it. Okay? So always force a fail the first time out. In fact, that first test case that they generated for us had a fail in it because that's kind of part of their methodology. Okay? All right, so we've shown that we're wired in. How do we do a toString? Well, again, we've already done some testing over in Counter Client. We don't have to reinvent the world. So what we did is we constructed one and then we printed it and we looked at the value. Well, we're going to do something a little different this time. Okay? So let's go over to counter test. Let's copy the code where we constructed one in C2. And now, there's something that I just want to point out. I'm going to change C2 to C1 because these are separate methods. We don't have to worry about a collision between the variable names. So we can reuse them. And something that works out reasonably well is copy pasting. So I copied that construction of C1 from counter client, but I could have just simply copied it from the first test case. Let's just put that down there. And I don't have to worry about the names colliding because they're in different methods. Every method has its own namespace. Okay, that's great. Now, I don't want to inspect it visually. The problem with inspecting it visually is it's very time consuming. And you have to really understand the lifespan of these tests. These tests, these JUnit test classes, they begin to travel around with the production code and they have a life that's as long as the production code. And so anybody who's trying to configure the system and then make sure they haven't broken anything or to do maintenance or expand the system, they're going to want to use and run all the test cases, and they're not going to want to know what to look for. Okay, so this idea, the approach that we've been using of printing to the console and inspecting was a good starter approach, but it doesn't have a lot of legs down the line. Okay, so let's do this. Let's put it in a string. So let's say string expected equals, and what am I expecting this thing to look like? Well, let's just go over in counter client. Let's run counter client. Okay, run it. Uh-oh. Go right ahead. Oh, counter value equals 0. Okay, so we're going to say counter, and that's it. So what are we going to expect? We're going to expect it to be equal to 0, right? Well, let's just take this. Let's just cheat a bit. This is what we're expecting this string to look like, okay? Back to counter test and saying this is the string we're expecting to get back. Right there. Uh-oh. I don't have my quote marks in the right spot. Okay. Oh, I don't have them in the right spot yet either. I want it before counter, don't I? Yes, I do. Just like that. Okay, so that's my expected. All right. Now, how do I get my actual? Okay. Well, let's do this. Let's say string actual equals C1 call toString. ToString. Okay? So now I'm expecting that those are going to be equal. Okay. Now I'll show you a couple of ways that we can test this. There are a couple of different assertion methods that will work. Okay? First of all, in order for this equals to work, we're going to want to make sure we call dot equals. Okay? So here's what we could do. We could say Boolean result equals, and then we could say expected equals actual. Okay, so if expected dot equals actual, which would work if our if we did this the right way, then we're going to get a true. Okay, and then we could say, instead of saving the result, we could use an assert true. This is a good one. There's assert true, assert capital T for true. Expected equal result. All right, so if in fact they are equals, we're expecting to get a true, assert true. Let's see. Yes, it worked. Well, that's a little bit roundabout, okay? It turns out that we have a really powerful method called assert equals. So let's try that. Assert equals expected, comma, actual. Let's see if that works. Save and run. It does work. So it turns out that assert equals is a really, really powerful method. Okay? In fact, it's a family of methods. Something we haven't really talked about except for constructors so far is we can overload a method. We can have a method of the same name that expects different parameters. So it turns out that if you call assert equals with string and string, it will compare them using dot equals. And how does it know that? Well, because it knows that it's being called with a string and a string, and there's actually separate code for that. So when we have more than one method in a class with the same name, we call that overloaded. That's the reason why in the car class, when we created a second constructor, one that took essentially all the arguments instead of no arguments, I called it the overloaded constructor. Okay. So it turns out that assert equals is very powerful. There are several versions of it. And the version for string and string compares using dot equals, not equal equal. Pretty nice, huh? Okay, so that did what we wanted. All right. So there's a real I just want to point out that when you're testing a toString, you can spend a lot of time trying to build up the expected value. Okay? Uh, and what I did is I kind of cheated. I had another client, I had another testing client that I was able to run. Okay? And I went, oh yeah, that's the value. Okay? Now, I've got to tell you that normally when I code the test case for a toString, I do an equal amount of cheating. Okay? Because typically I can predict what the values will be. I just want the test in there, especially if we later we change the class and we give it more instance variables and we regenerate the toString using Eclipse, then I'm going to want to make sure that I've come back and I've changed the test case for the toString. So here's a cheat that I do. I'll show it to you if it appeals to you. Well, usually it appeals to my students, so I think I've taught them well. Okay, so what I'm going to do is I'm going to cheat, and in the beginning I'm going to say the expected value is the empty string. Well, I know that's not true, and I know that's going to fail. Well, that's okay because I needed to fail the first time anyway to prove that I've got a properly functioning test case. So I'm gonna save that. It's already saved. I'm gonna run it. Now that's gonna fail. Now I'm going to show you another feature that you haven't seen so far. So let's see. Test toString failed. Test no arg constructor passed. Okay. Now let's go down here, the failure trace. Okay. Now if you come out here, you can see it says expected empty string, but was, and then you've got the value. Oh, that's interesting. So one of the reasons that we always put the expected first when we're doing assert equals and the actual second is that this error message assumes that the first one was the expected and the second one was the actual. Okay, so then this error message comes out in a useful format. Apart from that, it only knows that they're not equal, right? Unless you put them in the right order. Now, if you double click on this line, here's my sheet. It pops up a little thing where you can see the difference between these two. Well, I don't want to compare the difference. I know the difference. I just want to right click over here and copy the text out of that. I clear this. Okay. Now I go over and now I know what the test is and I paste it. Okay. Now this is going to pass. Okay. Now, this is cheating in a way, okay? But it's not completely cheating. What we've just done is that when I looked at that failure and I saw that I was getting counter value equals 0, I inspected it. I visually inspected it. And I said, well, given the current design for this class where it's got one instance variable, value, then that's a proper answer. So I'm going to, having inspected it, I'm just going to put that value into the string expected, and then I'm going to automate that test. Now the only time that that's not going to be true is at some kind of a later time if we have another instance variable for the counter and we regenerate the toString and we don't come back and change this test case, it's not going to match. It's going to fail. And that's fine for me. Okay, that's what I want. I'll go, oh yeah, I regenerated the toString method, but I never changed the test case code. Okay, let's go back and change the test case code. And you would go back and inspect it again and it would be fine. Okay, so A little cheating on that is fine by me. All right? Okay. Now what's the next thing that we test? Let's go back to counter client. We test equals, okay? And what are we testing? Okay, so we're creating two counters. We're doing an equal test. We're expecting it to fail. And we're doing a dot equals test, and we're expecting it to pass. Okay, let's do that. So let's just copy these. Okay. In fact, let's copy all this code. This is not such a bad idea. So we're going to copy all this. We're going to come over here. We need another test case. Okay. So capital TEST, public void test equals. Okay. That's void does not have a C in it. It has a D. All right, that's looking good. Now, let's just prove this is wired in. Okay, because you'd be surprised how many tests are not actually running when I see students' code. Okay, so that did fail, so we know that test is wired in. Very good. Okay, and you remember I have on my clipboard, I have the code from the other tests. So we've got two counters. Okay. So let's do this. Let's use an assert false. Assert false. Okay. And then just take this C3 equals C4. That should come back false. And then let's follow that up with an assert true. And let's take this other expression, C3 dot equals C4. Okay, I don't think I've got too many. That should be right. Ah, that's right. Of course, I don't need those two printing lines because now we're doing them with assertions. Okay? So it's really nice. There's an assert false, assert true. There's a lot of different assertions that you can use to test just in the style you want to test. So we're going to save that, and we're going to expect this one to pass. Okay. Now, this is the first time that we put more than one assertion in a test case. And if you read around a bit, you'll find that some people are really extreme and they'll say only one assertion per test case. And they have all kinds of reasoning for that. But I think in the end, that really doesn't pan out. For me, you can have more than one assertion in a test case if you're only testing one thing. Okay? Now, when we're testing an equals, it should fail the equal and it should pass the dot equals. Okay? Those are just the two sides of the same test. I feel completely comfortable having those two assertions in the same test case. All right. Now, you're going to see as you see me do these tests over time that, especially with equals, that there's a lot of times where I want more than one test case. This is especially true if, let's say, there's more than one instance variable, and when we generated the equals, we say that we're not concerned with all of them. Like with car, I said I wasn't concerned with vehicle identification number, okay? So I want to prove to myself that differences in VIN do not cause equals to fail. But then I want to prove individually that differences in make calls equals to fail, in model, in year, in color, in etc. Okay, so I'm going to need 5 or 6 test cases for equals when I have a bunch of instance variables. But here I just need one. And let's go back and see what I did here. I'm getting pretty close. I test increment and I test decrement, and I'm done. Okay, well, let's borrow that code again. That was working pretty well, right? So let's create another test case. Now, while I'm typing this, I want to tell you something that you really have to keep in mind. There is no knowing I'm sorry, this is test increment. There's no controlling what order these test cases run in. And so you might say, "Oh, Kevin, they're in this, order in the source code. Of course they'll run in that order." No. Okay. So you may see them run in that order, but you can't rely on that. Okay. Now, when we're not sharing any code, it doesn't really matter. Okay. We run one, we run another, or we run one, we run the next, we run the next, we run the next. It runs all of them just once, one after the other. Okay. As long as we don't have any common code, this before, which we're not using yet, has a common code. Okay, and so we are kind of concerned about the common code to a certain extent. But here, we're not creating any common code, so we're not really relying on any kind of order. So we're fine. So test increment, the first thing we do, force it to fail to make sure it's wired in. So we fail it, working just fine. And then let's just take the code that we copied, okay, and we've incremented it. We're expecting 1. Okay, let's do this. So let's declare an int called expected. Okay, equals, oh, I'm sorry, we don't want to do that. Never mind, let me back up. So we do want to increment it, then we want to use the value. Okay, so let's declare an int called expected equals 1. Okay, and let's have, and then the other one, here, sorry. Oh yeah, we can do this. And then, sorry, int actual equals C5 get value. All right. Now we're expecting these to be equals. In fact, we're expecting them to be equal. Now, if we use assert equals, Java knows, because these are ints, that it's going to call the version of the method that compares them as ints. So we say expected, comma, actual. Works just fine. There is a version of assert equals that works with the 2 ints. It uses the equals test, by the way. And let's give it a run. And that's working fine. Okay, now I'm going to show you the last time that, of course, you probably got this idea so far. You can clone test cases. So here we've got one where we've cloned one. Okay, so as soon as you clone one, you've got 2 things that are called the same. You don't want that. So instead of increment, we want decrement. Okay. And instead of calling increment, we want to call decrement. right? Instead of expecting 1, we're expecting -1. And then we want to get the value for the actual and compare them, and we think that's going to pass. So let's see. It appears to have passed, but I just want to point out that we haven't really proved that we're running this test. So I always want to come back, even now, throw a fail in, force this test to fail, so I'm absolutely sure it's running. Yep, it is. Take that out. Save it. And off we go. All right. So, let's see. You know, I was going to show you the before code, but I'm going to tell you we're not going to use the before code quite yet. We'll wait before we're using common code. It's not going to drive a lot of value in this particular instance. Okay, so had we not checked the box, it said that we wanted the before code, we wouldn't have gotten it. All right, so I'm just going to get rid of that. Okay. So, this is working fine. All right. Let's say that somebody comes along and they want to add another requirement. Okay, well, what kind of requirement could we get for a counter? Well, we've kind of reused all of we've kind of used all the functionality that a proper counter has, except for reset. Okay, so since we're always saying that the initial value of our counter is 0 by definition, if we reset a counter, we reset it to 0. Okay, now how could we do that? Well, right now, before we learn about test-driven development, I'm going to have you do this. We're going to come into counter. We're going to come into counter. We're not going to worry about counter client anymore because we've already used all that code, right? So we've got increment, decrement. We need another method. So let's just put in the method and then we'll test it. Okay. Public void reset. Okay. And what are we going to do? We're going to set the value to 0. Okay, let's do that. Set value 0. Okay, does that make sense? All right. Okay, so let's go back to our test. Does our test still run even with new code in? Well, yeah, we didn't change any code. We only added code. So it should run. Yeah, ran. It succeeded. But we need new test cases. Okay. So let's add a test case. Test. Public. Void. Test. Reset. Okay, so why don't we fail it first while the failing's good. We had that. Okay, so hooked up for sure. Okay, so let's go up and steal some code. So we've got a counter here, and we've got a decrement. Okay. So that's going to push it to -1, right? Let's reset it. Reset. Okay. Now we're going to expect it to be back to 0. So let's say int expected equal 0. And then let's say int actual equals C5 get value. And let's finish that with semicolon. And we want to, the assert equals is going to compare those two. I'm just going to poach a copy of that from up ahead. Okay? And now I'm going to expect them to be equal. So save it, run it. That's it. So when you, once you have a test, the class that's a companion to your production class, you can use it to make sure that nothing has happened within the overall environment or in the production class itself to break, so you can run the class, the test class whenever you want. Then every time that you go to change the class and add functionality or change functionality, here's how I want you to proceed. First, run the test. Okay? You'd be surprised how many times you come along and somebody, perhaps you, has broken the class, but you don't know it. Okay? So changing a broken class compared to changing a working class is a big difference. So if you test it and it fails, then the first thing you have to do is to fix the class. Okay? Then when you have a test that passes, then you go and you add your functionality or you change your functionality. If you're just adding extra methods, then you add the test cases for the method or methods that you need. If you've changed how methods work, then you might want to change some test cases. You might eliminate a few test cases. You may want to add some test cases, and you want to test it every which way you can. And when you're done, you should have a test class that passes. Now, I just want to point out that I know we only have one test class, but right now, if we look at this test folder, okay, I can go down to my class, counter test, and I can right click and say run as JUnit test. And it will run just that one test. Okay? Even if I had 20 test classes in this package, okay, and typically I'd have one for every production class associated with the package, I can highlight the package and say run as JUnit test. Okay, and now, of course, we're only running the one test, but that's only because there's only one there. And then you can actually, for an entire project, you can go to that test folder. That's why we created it. And you can right-click on it, and you can say, run as JUnit test. And that will run every test in every package in your project. And of course, at any particular time when you're done with a class, all the classes should pass. So I think this is a good introduction to JUnit. There's an assignment that goes with this, having you do sort of the same kind of stuff with the pedometer. We're going to have you test it using JUnit and have you add a little functionality to it, just like I did with the counter. So good luck with that, and I'm going to say bye until next time. Bye-bye.